This lesson we're going to be looking at prime factors, and by the end of the lesson we'll be able to find the prime factors of numbers, be able to find the lowest common multiples and also the highest common factors. So to start off with, we want to find the prime numbers which multiply to give 140. So if I think of the numbers which I can multiply together to give 140, I can have 14 times 10. But 14 and 10 are not prime numbers, so I can break each one down. So the 14 I can write as 2 times 7, and the 10 I can write as 2 times 5. Now we have a set of prime numbers, so 2, 7, 2 and 5 are all prime numbers. So if I multiply them all together, I get back to 140. Okay, so the prime factors of 140 are 2, 7 and 5. Okay, we want to find the prime factors of 150, but we want to be able to do it using a prime factor tree. So I start off with 150, it's the same process. Okay, what two numbers multiply together to give me 150? I'm going to do 2 and 75. 2 is a prime number, so I can leave that. 75 is not a prime number, so I can split that up. 5 times 15 gives me 75. 5 is a prime number, so I leave it. I look at the 15 and I've got 5 times 3. So now my prime factors are 2, 5, 5 and 3. My prime factors are going to be 2, 3 and 5. Okay, if we want to write 150 as a product of its prime factors, we're still going to use those numbers, but because they need to be a product of the prime factors, we're just going to multiply all of those together. So I've got 2 times 3 times 5 times 5, and just to make it a little bit neater, that's 2 times 3 times 5 squared. 5 times 5 is just 5 squared. Okay, let's try another example. So we want to find the prime factors of 275. So I start at the top, 275. What two numbers multiply together to give me that number? I'm going to choose 5 and 55. 5 is a prime number, so I can move on to the 55. I can get 55 by doing 5 times 11. Now we have our prime factors, okay? They are all prime numbers. 5, 5 and 11 are all prime numbers. So the prime factors are going to be 5 and 11. And then I'm asked to write 275 as a product of its prime factors. So that's going to be 5 squared times 11. That's just 5 times 5 times by 11. Okay, for each of these you're going to write the numbers as a product of prime numbers using factor trees. So we start off with 126, and I need to think what two numbers multiply together to give me 126. The easiest one to start off with is the 2. 2 times 63. Okay, and then you need to think what two numbers multiply together to give me the 63. 3 multiplied by 21. Now what two numbers multiply together to give me 21? 3 and 7. Now I have all of my prime numbers, which are 2, 3, 3 and 7. So writing it as a product of prime numbers, I'm going to have 2 times 3 squared times 7. So go through these questions, set it up using the factor trees, and then I'll go through the answers with you. Okay, so here are the answers. Okay, we're going to have a look at the lowest common multiple. So if we're asked to find the lowest common multiple of 4 and 10, we first need to list all of the multiples. Okay, so that's the first thing. We're going to list all of the multiples and then find the smallest multiple which appears in both. Okay, so if I list the multiples of 4, I've got 4, 8, 12, 16, 20, 24 and 28. The multiples of 10 are 10, 20, 30, 40. And then the lowest common multiple is my smallest multiple which appears in both. So 20 is the smallest multiple which appears in both the 4 and the 10 times tables. Let's try another example. So find the lowest common multiple of 18 and 24. Again, you list all the multiples for each number, and then you find the smallest multiple which appears in both. So in this case, for 18, 72, and then for the 24 we've got 72 as well. So that is my lowest common multiple for 18 and 24. Okay, another way to find the lowest common multiple is to use factor trees to find the multiples. So if we want to find the lowest common multiple of 10 and 35, using the factor trees, to get 10 I can have 2 times 5, and those are prime numbers. And then for 35 I can have 7 times 5, which are also prime numbers. Now if I look at the numbers that I'm given at the bottom, I can just multiply them together, but I do not want any numbers which have been repeated in both. So for example, I've got 2 times 5, so I've used the 2, there's no 2 here. I've used the 5, and there's a 5 here, so I don't want to use that one again. And then the only one left is a 7. So 2 times 5 times 7 gives me 70. So the lowest common multiple of 10 and 35 is 70. This method is useful when we have big numbers because sometimes the lowest common multiple can be quite large and we don't want to be listing loads of numbers. If I was to list these, I know that I've got 10, 20, 30, 40, 50, 60, 70, and I'll just go to 80. So this is just to check that we got the right answer. Multiples of 35 is going to be 35, 70, and then 105. So from this, we can see that 70 is the first multiple which appears in both. Okay, so if we try it for the next one, so for 4 and 6, for these ones you could probably just list your multiples, or you can use your factor trees. So the first one, if I just list my factor trees for the 4, I've got 2 times 2, and then for the 6, it's 3 times 2, and these are all prime numbers. So I've got 2 times 2, and then times by 3, which is just 4 times 3, which gives me 12. Okay, so go through these questions and write down your answers. And also, once you've done that, just have a think about what you notice about these numbers and its lowest common multiple. So here are the answers. And then you should have noticed that you just need to multiply the two numbers together. So 5 times 6 gives me the 30, and that's also the lowest common multiple. 3 times 4 is 12, that's also my lowest common multiple. Okay, go through these next questions. For these ones, it's probably easier to use the factor trees. So if I go through the first one with you, for 10 and 15, 2 times 5 gives me 10, and then 3 times 5 gives me 15. So to find the lowest common multiple, I've got 2, I've got 5, and I've got 3. So 2 times 5 is 10, times by 3 gives me 30. So use this method to answer these next questions, and then I'll show you the answers. Okay, so here are the answers: 30, 12, 30, 35, 18 and 12. Okay, and just have a think, does the connection you found in the last question still work, and why? Okay, so in the last question we could just multiply the two numbers together and it gave us our lowest common multiple. This time that does not work. Okay, we've got bigger numbers, So there's more chance of us having a lower common multiple, which is not just multiplying our numbers together. For this next one, you're going to find the lowest common multiple for these numbers. I'll go through A with you. You're going to use factor trees because the numbers are getting a little bit more tricky. So we've got 18 and we've got 12. So to make 18, I can do 2 times 9. 9 is not a prime number, so I break that down some more into 3 times 3. So now I have all of my prime numbers. Okay, for 12, I can have 6 times 2, and then the 6 is just going to be a 3 multiplied by 2. So if I want to find the lowest common multiple, I've got 2 times 3 times 3 times 2. Okay, so that's just 4 times 9, which is 36. So that is the lowest common multiple for 18 and 12. You're going to do the same thing for the rest of these questions, and then I'll show the answers for you to check. Okay, so here are the answers. We're going to have a look at highest common factor, and we're going to find the highest common factor for 48 and 120. So we've already had a look at what factor is. Okay, so a factor is just a number which divides exactly into the number given. And we want the highest common factor. So common means it needs to be the same in both of the numbers, and we want the highest number possible. So if we just go through this example, the highest common factor for 48 and 120, you're going to do your factor trees. So for 48, we get 24 times 2. 2 is a prime number, so we move on to 24. We can get 24 by doing 2 times 12, and then we can get 12 by doing 2 times 6. And then the 3 times 2 gives us the 6. If I do the same thing for 120, I get 10 times 12. If I break down the 10, I get 5 times 2, which are both prime numbers. If I break down the 12, I get 2 times 6. And then if I break down 6, I get 2 and 3. So my prime factors for 120 are 5, 2, 2, 2 and 3. Now if I want to find my highest common factor, I need to take numbers which appear in both, okay, because we have the word common here, so it needs to be common to both. I can see that there are 2's on both sides, so I've got a 2 here and a 2 here. I've got another 2 which appears on both sides, another 2, and then I've got a 3. Okay, there are no other numbers which appears in both. There are no more 2's which I can match up with, and there are no 5's in the factors of 48. So now if I just work this out, 2 times 2 times 2 is 8 times by 3, and that gives me 24. So my highest common factor of 48 and 120 is 24. Okay, if I want to find the highest common factor of 24 and 56, again I'm going to use my factor trees. So the factors of 24 can be 2 and 12, factors of 12, 2 and 6, and then the 6 can be broken down into 2 times 3. For 56 I've got 2 times 28, 28 can be split into 2 times 14, and 14 can be split into 2 times 7. So again, I need to find the numbers which appear in both. So I've got 2 and a 2. I've got another 2 in both of those, and then a third 2. 7 does not appear in both, and 3 does not appear in both. So this is my highest common factor, 2 times 2 times 2, which is 8. So the highest common factor of 24 and 56 is 8. Okay, so you're going to find the highest common factor for the following pairs of numbers. You're going to use your factor trees, and then you're going to find the common factors in both of those numbers. So here are the answers. If you got any of those wrong, just go back and check your factor trees. Make sure that you've got the correct numbers which are multiplying together. And then also make sure that you haven't repeated any prime factors at the end. Okay, so remember it can only appear in both of those and you only list it once. So going back to this question, we've got 1, 2, 3 2s, 1, 2, 3 2s in both of those. Okay, to finish off, I've listed some games here that you can play in your own time. I'm going to put them in the description. If you want some extra practice, then exercise 1.4 and 1.5, pages 5 to 7, will give you some more practice with prime numbers, lowest common multiple and highest common factor.